This is differentiation and integral together. So solutions. Looking for solutions. So here we're dealing with the surface area generated along a certain position. So here's the question set: determine the surface area generated when the curve with y square equals to 2x when it rotated about the x-axis for x equals to 0 and x equals to 1. So we are going to use this equation. So first of all, we start with the inside part and then go along the brackets, putting square root, and starting by solving the variable of y, you have something like this as our y. We square both sides and then it becomes like this, and then y is the same as this, is the same. So first of all, start with the inside part. We derive, this is the steps. You deriving this one is like adding 1, subtracting 1 here, and multiplying by half in front. So you multiply by 1 over 2 in front, which is and then when you put -1, it's like you will be left with 1 over 2, and then we have to multiply by the derivative of the inside part because it's a composite function, a function inside of a function. The outside function is the one that we started with, and then the inside function is 2x. So deriving 2x will have 2, and then from here, as you can see, the 2 they can cancel out, and then here this is a negative exponent. To make a positive exponent, what do? You put it underneath. Because it's a square root, you just put the square root and then you have 2x. Now we're done with dy over dx because we're dealing with the part which is inside, and then brackets. Now we put brackets square. So putting the brackets in the equation, we are dealing with the, so putting this one inside the equation, you have something like this, and then squaring it, that means you square the top part and the bottom part. So squaring 1 will have 1 square, and then squaring the bottom part will have 2x. Now we are done with the squaring part, and then now we have to add 1, adding 1. So it's like we are at this point of adding 1. So it's like we're taking this one and add 1. So we'll take is it, and then you will have to make a common factor, 2x a common factor, and say 1 goes how many times here, because here 1 is over 1, we are making it a fraction. So 1 goes how many times? 2x. So we'll write 2x here, and then 2x goes how many times here? 1. So we'll say plus 1, and then you say we at this point now we have to put the square root sign, this point. So we put the square root sign, and then we have 2x plus 1 divided by 2x. So the square root, it can be divided, like you can put it on top and the bottom part, it's okay. So 2x plus 1 over square root of 2x. Now we are done with the square root part. So now, as you can see, it rotated about the x-axis, so we'll put the value of y here. So making y the subject to the formula we already did, which is this one. So we are going to the equation now. We have to put everything there. So we can take 2 pi out as it's a constant, and then because we are given the limit as 0 and 1, we'll put 0 and 1, and then y. What happened to y? Y will take the equation that we have made the subject of the formula. Instead of putting y, we'll put this one because this the equation is the other side of the equation, and then our square root sign is this one, so the square root sign, the part of the square root sign is this one. Because we have b of x, we can put d of x here. Okay, now we cancel this one because they are the same. From here, as you can see, there's 2x, and in the equation, what is it when we make y the subject of the formula? It's square root of 2x, so they will cancel each other because they are the same. So now we are left with this one, so let's continue. 0 and 1, so we have something like this is a square root sign. We're left with this. Now at this point of time, 2 pi, and then this one is the same as this, not forget the limit 2x plus 1. It's the same as raised to this one if the square root is the same as this one. Okay, adding 1 here because we are integrating, so integrating this one, we have something like 2x plus 1. We add 1 here on top of a half like this, and then we add like this. As you can see, there's a function inside a function, so we must also take care of the inside function. So you'll have what, 2, and we'll put our limit as 0 and 1. So adding the inside part, we have something like it's like this, 2x plus 1 all over. So this is 3 over 3 over 2. So this 2 will cancel. This means a multiplication. Let me change it first because it doesn't make any sense at all. So it will be like 3 over 2, 3 over 2 multiplied by 2, and then this 2 will cancel this 2. We have 0 and 1 here. 2 pi 2x plus 1, then 3, 0 and 1. Then we'll put everything inside the equation, manipulating the equation. So putting 1 here, we have 2 plus 1 is 3, so we have 3 over 3, and then substituting by 0 again the other side, you have 0 here, so we have something like 1 over 3, 3 over 3, the common factor is the same, so we'll have something like 2 pi. Adding this one, it's 2 over 3, then 2, the answer is multiplying, they have 4 pi over 3, so it's a unit square. So thanks for watching. So if you like, comment, like, share. To others. So this is the answer. Thanks for watching.